Welcome to 6.2 Trigonometry, Triangles and Angles. Okay, use common sense to match the variables and the values. The triangles are drawn to scale and the angles are measured in radians. All right, so think about radians. 180 degrees is pi, which is 3.14 radians. 90 degrees would be 1.57. So if we look at number one, alpha here is a small angle, about 30 degrees. And 90 degrees is going to be 1.57. So a third of 1.57 is probably going to be 5, okay? 0.5, all right? So if we look over here, and do we have one close to 0.5? No, it's either 0.28 or 1.29. Okay, so these are the two possible angles. These other ones, 7, 24, and 25, those are lengths of sides, which could be, these could be as well, but I'll get to that in a second. So between 0.28 and 1.29, obviously alpha is smaller than beta here, so alpha must be the 0.28, all right? So that would go there. So if we draw a line, so that's B. And then that means beta is going to be the 1.29. Okay, so then we have 7, 24, and 25 left over. So let's just think about this. Z is going to be the longest, so that must be E for 25. And then obviously X is the smallest, so that's A, and Y must be 1.29. So that's your common sense approach to this. All right, so let's do the next one. All right, again, alpha and beta are both the same. That's what these lines here mean. They're equal in value. So are there any of these that are equal in value over here? So we have 23.35, 16, 17.82, and 0.76. Okay, so they're saying they're the same, but obviously looking at all of these answers, none of these are the same values. So something must be off just a little bit. And if alpha and beta are the same, then base angles theorem says x and y are the same. So they're not really exactly the same, but they're going to be the closest values together. So radian measurement from the last problem, we know that D and E must be alpha and beta. All right, and it's hard to tell which one's bigger because they're so close together. So we're just going to put alpha and beta down to that circle. And then for the lengths of the sides x and y, 16 and 17 are the closest together. So x and y must both go to those two. And then z is the hypotenuse, which is always the longer side, 23.35. All right, I think that last problem, number 2, is a crappy problem when they put those lines on there. Find the values of the 6 trigonometric functions for the angle theta. All right, so what that means is the sine of theta and the cosecant of theta, and then you have the cosine of theta, and that goes with the secant of theta, and then tangent of theta and cotangent of theta. So here's how easy this is. Sine of theta, if you remember SohCahToa, so I'll write it up here. SohCahToa. So these are all fractions. The sine is opposite over hypotenuse, and the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Okay, so the sine of theta in this position at theta. Okay, here we are at this corner. Opposite leg is 4 over the hypotenuse. Hypotenuse is always opposite the 90-degree angle, so 4/5. And cosecant is the reciprocal of that. Now cosine is the adjacent leg. That's a 3 there, by the way. So that's a 3 over the hypotenuse, 5. And the secant is the reciprocal of that, 5/3. Tangent is the opposite over the adjacent, so that's 4/3. And the cotangent is the reciprocal of that. That's how you should think about it. All right, so again, let's go to number 4. You try it and see if you can get them right. Sine of theta and cosecant. I'm going to get a little more room here. Cosine and secant. and the tangent and the cotangent. All right, sine of theta is opposite 8 over hypotenuse. So the cosecant is the reciprocal of that. And the cosine is adjacent, 15, over hypotenuse, 17. Secant is the reciprocal of that. And the tangent is opposite over adjacent. And the cotangent is the reciprocal of that. Okay, and that's how you do those. Let's do it again. Let's see if you can do them quickly. So from this corner, we're at theta. So this is your opposite, this is your adjacent, and this is your hypotenuse. So I'm going to leave off the theta thing here so we can write faster. Sine of theta is opposite over adjacent. And you're like, oh crap, I don't have the adjacent side. So you have to use Pythagorean theorem to figure it out. So we'll call it x. So x squared plus 2 squared equals 5 squared. So x squared equals 25, and we're going to subtract the 4 from that. It's 21. So that's the square root of 21. So that'll be over, 2 over 5. That's your hypotenuse. That's the sine of theta. But we had to get this figured out here for the adjacent side. So the cosecant is the reciprocal of that, 5 over 2. Then we go with the cosine of theta, and that's the adjacent side, square root of 21 over hypotenuse. And then we have the secant of theta is the reciprocal of that. So you have to multiply, or you have to rationalize. So that's 5 square root of 21 over 21. In the back of the book, they don't do that. I expect you to do that. Okay, so then we have tangent of theta is the opposite over the adjacent. Again, you need to rationalize 2 square root of 21. It doesn't take you very long to do that, so just do it. And then you reduce it if you can. That one doesn't reduce. And the cotangent is going to be the square root of 21 over 2. Didn't write that very well. Okay, so now let's do the next one. We got to use Pythagorean theorem. Again, x squared plus 1 squared equals 3 squared. X squared equals 9 minus 1 is 8. Square root of 8 is 4 and 2, or 2 square root of 2. All right, so that's x, 2 square root of 2. All right, let's do these. Sine is opposite over hypotenuse, so the cosecant is 3. And then you go cosine, it's opposite, or excuse me, the adjacent over the hypotenuse. Okay, and then the secant is the reciprocal of that. So 3 over 2 square root of 2 multiplied by the square root of 2 over square root of 2. That's 3 square root of 2 over 2 times 2, 3 square root of 2 over 4. And then the tangent is going to be opposite over adjacent. So again, multiply by the radical. And you get the square root of 2 over 2 times 2, or the square root of 2 over 4. And the cotangent is the reciprocal of the first, which is just going to be 2 square root of 2. All right. Number 7. All right, so here we need to figure out what all these lengths are. All right, so this is c, but you got to calculate it using the Pythagorean theorem. A squared plus b squared equals c squared. So what's c equal? C is equal to the square root of a squared plus b squared. You can't just put c up there, okay? That's what c is. Okay, so sine of theta is opposite over hypotenuse. And for now, we'll go ahead and leave this like this. You don't have to rationalize this. If you have numbers down there and we want to calculate, go ahead and do it. All right, so the cosecant then is the reciprocal, the square root of a squared plus b squared all over a. Cosine is the adjacent over the hypotenuse. And the secant is the reciprocal of that, a squared plus b squared over b. Okay, and then the tangent, excuse me, is opposite over adjacent, and the cotangent is the reciprocal of that. All right, so let's put this over here. Now number 8. We'll call this b. So what is b? So a squared plus b squared equals c squared. So what is b? We have to subtract the a squared, and then we take the square root. So that is the square root of c squared minus a squared. Sine of theta. Theta is up here now. Opposite is the square root of c squared minus a squared, all over the hypotenuse. And so the cosecant is the reciprocal of that. And then the cosine is the adjacent, which is alpha, or a, over the hypotenuse, c. And the secant would be the reciprocal of that. And then we do the tangent is opposite over adjacent. And the cotangent is the reciprocal of that, a over the square root. Wow. Square root of c squared minus a squared. Hard to see. Number 9, do the exact same thing again. We'll call this a. So what does a equal? So a squared plus b squared equals c squared. So a squared is c squared minus b squared. And you take the square root. So that is c squared minus b squared. And you do the whole thing again. So we'll keep doing this until you get really fast at it. So again, which corner are you at? You're at theta. So the sine of theta is opposite over hypotenuse. So the cosecant is the reciprocal. And the cosine is adjacent, c squared minus b squared, over the hypotenuse. And the secant is the opposite, or the reciprocal, c squared minus b squared. So tangent is the adjacent, or excuse me, opposite, b over the adjacent, c squared minus b squared. And so the cotangent is the reciprocal of that, c squared minus b squared, all over b. All right, so now look at what we have here. These two are the same, so that means theta is 45 degrees. Later on, we'll get better at what that means. So this is 45 degrees. Again, we'll call this c. So what does c equal? A squared plus a squared equals c squared. C equals the square root of 2a squared. That's how you should look at it. All right, so now start the process. Sine of theta is opposite over hypotenuse, a over c. What was c? C is the square root of 2a squared. And again, you should know what that is. A squared, you can take the square root of a squared, and then look what happens. That's 1 over the square root of 2. And we rationalize that, and that's the square root of 2 over 2. All right, so I'm going to write what this is. This would be a square root of 2 for c. So the cosecant is the reciprocal of what we have for sine. So that's just the square root of 2. Cosine is the adjacent over hypotenuse, a square root of 2. So that's 1 over the square root of 2. And you rationalize that. You get the square root of 2 over 2. And then we have tangent, we got to do secant, is the reciprocal of that, which is the square root of 2 as well. All right, so let's do tangent over here. That is the adjacent over the opposite, which is 1. And the cotangent will be the same thing. The cotangent is going to be 1. Reciprocal of 1 is 1. All right, number 11. And the exact values of x and y. That means don't use a calculator. So 30 degrees. All right, so 30 degrees is, as far as we know, if you think of your unit circle, the sine of 30 degrees is your y value in your coordinates. And that is going to be the short leg, which is 1/2. Okay, so what we have for sine, the sine of 30 is equal to the opposite leg over the hypotenuse. All right, well, the sine of 30 is 1/2. So what is x? Cross multiply, x is 8. And the tangent of 30 degrees is 4 over y, opposite over adjacent. So we multiply both sides by y, divide off the tangent of 30 degrees. But what is the tangent of 30 degrees? So the tangent is your y value over your x value on your unit circle, which is 1/2 over the square root of 3 over 2, short leg over the long leg. So 1/2 over the square root of 3 over 2 is going to be 1 over the square root of 3. All right, so y equals, instead of rationalizing that, let's go ahead and just put it in here, 1 over the square root of 3. So now you have a fraction inside of a fraction. So we're going to multiply the top by the square root of 3 over 1. So y is equal to 4 square root of 3. All right, so those are your answers for number 11. Okay, number 12, same type of thing. So let's just do the sign again. It doesn't matter which one we do here to get x. The sine of 60 degrees on the unit circle is still the opposite leg, which is going to be the long leg in this case. And that would be square root of 3 over 2. Sine of 60 is square root of 3 over 2. So if we take the sine of 60, it's the opposite leg over the hypotenuse. Again, multiply both sides by x and divide off the sine of 60. So the sine of 60, we said, was the square root of 3 over 2. So the top times the reciprocal of the bottom gives us 6 over the square root of 3. Rationalize, and we get 6 square root of 3 over 3, which is 2 square root of 3. That's x. Now, the other thing you could do is use the Pythagorean theorem. So we could do that to get y. Y squared plus 3 squared equals 2 square root of 3 squared. You could also do tangent or cosine and figure this all out. But we're going to go ahead and just show you that Pythagorean theorem works. Y squared equals, the inside of the parentheses here would be 4 times 3, it'd be 12. When you square a square root, the square root goes away. And then you're going to subtract the 9. So y squared is 3, or y is square root of 3. So those are your x and y values. Okay, you're going to keep doing this until you get really good at it. Okay, same type of thing. 45 degrees means that this is 45, which means by the base angles theorem, y is 7. Okay, Pythagorean theorem, I can just do this quickly. 7 squared plus 7 squared equals x squared. 49 plus 49 equals x squared. You have 98 equals x squared. Take the square root. That's 2 times 49. So that's going to be 7 square root of 2. So x is 7 square root of 2 and y is 7. Okay, so if you remember your 45, 45, 90 rules, your hypotenuse is always the square root of 2 times a leg, but I don't ever remember it because I can do all of this. All right, here we go again. We have 30 degrees. Remember, the sine of 30 is the opposite leg, which is the short leg, which is 1/2. So sine of 30, sine is the opposite leg over the hypotenuse. Sine of 30 is 1/2. So cross multiply. X is 5. Again, I'm going to use the Pythagorean theorem. Y squared plus 25 equals 100. Y squared equals 75. That's 25 times 3, which is 5 square root of 3. So y equals 5 square root of 3 and x equals 5. Again, I'm going to use the sine of 60 degrees is the opposite leg. Let's do cosine of 60. Cosine of 60 is the adjacent leg, which is the short leg, which is 1/2. Makes it easier. So the cosine of 60 equals the adjacent leg over the hypotenuse. Cosine of 60 is 1/2. Cross multiply, 2y equals 8, y equals 4. So we use the Pythagorean theorem again. 4 squared plus x squared equals 8 squared. X squared equals 64 minus 16 is 48. Square root of 48 is the square root of 16 and 3. So that's 4 square root of 3. Right, number 16. 45, that means those two are the same. X equals y. All right. So the sine of 45 degrees is the square root of 2 over 2. So the sine of 45 is the opposite leg over hypotenuse. Sine of 45 is square root of 2 over 2. Cross multiply. Divide off the 2. And you get 2 square root of 2 is x and y. Find the exact values of the trigonometric functions for the acute angle theta. Okay, so we got to find everything else. So if sine of theta is 3/5, then the cosecant is 5/3. All right, so how do we do this? Just draw a right triangle. Okay, and sine is opposite over hypotenuse. So we don't know x. Let's get x. X squared plus 3 squared equals 25. And so x squared is equal to 25 minus 9 is 16. X is 4. All right, so now we can do cosine of theta. Cosine is the adjacent leg over hypotenuse. So the secant is 5/4. And the tangent is opposite over adjacent. And the cotangent is the reciprocal. Okay, let's do the next one. Again, you have a right triangle. Cosine is the adjacent leg over the hypotenuse. So 8 squared plus b squared equals c squared. So 64 plus b squared equals 289. So 289 minus 64 is 225. So b is 15. All right, let's do it. I got cosine, so that means secant is the reciprocal, 17/8. So the sine is opposite. Again, we're making theta here at the first corner. Sine of theta is 15 over 17, so the cosecant is 17 over 15. Tangent is 15 over 8, and the cotangent is 8 over 15. Pretty easy. Again, let's go ahead and just put theta there. Tangent is opposite over adjacent. So 5 squared plus 12 squared equals c squared. 25 plus 144 is 169. So 13 is c. So if the tangent is 5/12, the cotangent is 12/5. Sine is opposite over hypotenuse, and the cosecant is reciprocal, and the cosine is adjacent over hypotenuse, and the secant is the reciprocal. Number 20. So cotangent, it would be the adjacent over the opposite. So 24 squared is 576, I think, equals c squared. Okay, so 576 and 49 is 625. You take the square root of both of those, and you get square root of 625 is 25. Okay, let's finish it. Cotangent, so the tangent is 24/7. Sine is opposite over hypotenuse, so the cosecant is the reciprocal. Cosine is the adjacent over hypotenuse, and the secant is the reciprocal. All right, 21. Now we have the secant. Secant goes with cosine. So the cosine is adjacent over hypotenuse. So the secant is the reciprocal of that. The secant would be the reciprocal of the cosine. which is the hypotenuse over adjacent. So 6 over 5. All right, do your Pythagorean theorem. 5 squared plus b squared equals c squared. So b squared is 36 minus 25. B squared is 11. So square root of 11. All right, so cosine is 5, 6. That's the reciprocal of secant. So the sine is the opposite over hypotenuse. And the secant is the reciprocal. So since it's a number, let's go ahead and rationalize it. 6 squared of 11 over 11. And the tangent is opposite over adjacent. And the cotangent is the reciprocal of that. So you have to rationalize that. 5 squared of 11 all over 11. Next one. Cosecant is 4/3. Cosecant goes with the sine. So the sine is the reciprocal. And sine of theta is opposite over hypotenuse. So a squared plus 9 equals 16. A squared equals 7. Square root of 7 is a. So now we have the cosine, which is the adjacent leg over hypotenuse. And the secant is the reciprocal. So rationalize that. 4 square root of 7 over 7. Tangent is the opposite over adjacent, so we have to rationalize that one. And the cotangent would be the reciprocal, so square root of 7 over 3. Moving on to 23. All right, so whenever you have these story problems, you got to draw a picture because all they are is just math problems. So you have a height of a tree, right? So there's the height of the tree. Forster, 200 feet from the base of the tree. So it's 90 degrees. We're going to say it's a perfectly straight up tree. Observes that the angle between the ground and the top of the tree is 60 degrees. Estimate the height of the tree. Okay, pretty simple. What have we been given? From this angle, that's the opposite leg and the adjacent leg. That would be the tangent. So the tangent of 60 is equal to the opposite over the adjacent. So 200 times the tangent of 60 equals y. The tangent of 60 is going to be the long leg over the short leg. So the long leg is square root of 3 over 2, and the short leg is 1 over 2. So 200 square root of 3. All right, so if we say 200 times the square root of 3, that gives us 346.4 feet tall. Pretty tall tree. So let's just do this calculation on your calculator. 200 times the tangent of 60. And that's 346.4. So it does work. They are exact. So here is the exact amount, which we always want to know. And then here is the estimate. Oh, I'm sorry. This is the estimate. Distance to Mount Fuji. So the peak of Mount Fuji from the very top is approximately 12,400 feet high. A trigonometry student several miles away notes that the angle between the level ground and the peak is 30 degrees. Okay, this is the short leg and this is the long leg. Estimate the distance from the student to the point on the level ground. Okay, so again, it's going to be tangent because you're dealing with the opposite and adjacent leg. So opposite over adjacent, which we don't know. Multiply both sides by the long leg, and then divide off the tangent of 30. So what is the tangent of 30? What's the exact value? Tangent of 30 is the short leg over the long leg. So 1/2 over the short leg over the long leg, 1/2 over the square root of 3 over 2 is 1 over the square root of 3. So if I take 12,400 divided by 1 over the square root of 3, that's the same thing as 12,400 times the square root of 3. This would be the exact amount, and then we use our calculator, times the square root of 3. That gives us 21,477.4 feet away. Divide that by 5,280. He said he was a few miles away. He was actually 4.07 miles away. Okay, 25. Stonehenge blocks. Stonehenge in Salisbury Plains, England, was constructed using solid stone, weighing over 99,000 pounds each. Lifting a single stone required 550 people, who pulled the stone up a ramp, inclined at a 9-degree angle, approximate the distance that a stone was moved in order to raise it to a height of 30 feet. Holy cow. All right, so 9 degrees, and how far did they have to pull the stone up the ramp? So the question is, are we talking about the hypotenuse? Let's use h. Or are we talking about this distance along the ground? Well, to get it up the ramp, I think that's what we're asking here. Okay, so let's find h. So since we're finding h, we'll leave x off. So what two pieces have we been given? The opposite and the hypotenuse. That's the sine. So sine of 9 degrees is equal to the opposite leg over the hypotenuse. So we multiply by the hypotenuse to get out of the denominator and divide off the sine of 9 degrees. So you use your calculator for this. So this is approximation here, so that's all we're doing is using calculator, and you get approximately 191.77 feet, or 192 feet is what they had to drag it. Advertising sign height added in 1990 and removed in 1997. The highest advertising sign in the world was a large letter I situated at the top of the 73-story First Interstate World Center building in Los Angeles. Okay, so you're 200 feet away. Here's the I. This is 78 degrees, so probably something like that, 78.87 degrees. So let's see how high the I is. Okay, so what have we been given? From that angle, we have the opposite and the adjacent. So we want the tangent of 78.87 degrees is equal to y over 200. Multiplied by 200 on both sides. So just take your calculator, 200 times the tangent of 78.87. And you get, let me do it again, 200 times tangent of 78.87. 1,016.6 feet high. That's a pretty big I, but I think what that is including the building. So it was hard to understand exactly what they were talking about, but I'm pretty sure the advertising sign was not 1,000 feet high. Okay, moving on. Telescope resolution. Two stars that are very close may appear to be one. Okay, the ability of a telescope to separate their images is called its resolution. The smaller the resolution, the better a telescope's ability to separate images in the sky. In a refracting telescope, resolution theta, can be improved by using a lens with a larger diameter. The relationship between theta in degrees and d in meters is given by the sine of theta equals 1.22 lambda over d, where I think that's lambda, is the wavelength of light in meters. Okay, the largest refracting telescope in the world is at the University of Chicago at a wavelength of lambda, 550 times 10 to the negative 9 meter. Its resolution is 0.0000, okay, whatever, approximate the diameter of the lens. Okay, so we have the sine of theta. Equals 1.22 lambda. Actually, we do that backwards. Lambda divided by d. Okay. All right, so we're solving for d. Theta is this degree, and wavelength is lambda, which is that number. All right, so they gave you the formula and the numbers. All you got to do is do algebra at this point. So you have to plug things in the right positions. But all of these story problems are like that. Okay, so we have to take the sine of 0.12340 zeros, 3769. 1.22 times lambda. Lambda is 550 times 10 to the negative 9. And that's all divided by d. All right, so first of all, sine. 0.12343769. So that is going to be, holy cow. I'm going to use scientific notation because I know you don't want me to. So 1, 2, 3, 4, 5, 6 zeros. So 6.58 times 10 to the negative 7. Let me make sure that's right. 1, 2, 3, 4, 5, 6, 7. Yep. Equals, let's see here. Negative 9 means the decimal gets moved to the left. I'll just do 550 times 10 to the negative 9. Oops. 550 times 10 to the negative 9 times 1.22. Again, I'm going to use scientific notation. 6.71 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. Negative 7 again, all over d. So now it's just algebra again. I'm going to multiply by d on both sides. And then I'm going to divide off that to this side. So d is equal to 6.71 times 10 to the negative 7 all over 6.58 times 10 to the negative 7. Well, that's just 1. So now all I have to do, the diameter of the lens is 6.71 divided by 6.58. 1.02. All right. Let's see, what is that in meters? 1 meter? Holy cow, that is a very large diameter for a lens. But that's the largest one at University of Chicago. So 1 whole meter is the answer. All right, moon phases. Phases of the moon can be described using the phase angle theta. All right, so we look at the picture as we're reading this. Determined by the sun, the moon, and the earth, as shown in the figure. Because the moon orbits Earth, theta changes during the course of a month. Okay, the area of the region A of the moon, which appears illuminated to an observer on Earth, is given by, so there's our formula. All right, so that's the area of the moon. And where R in the formula is 1,080 miles. That's the radius of the moon. Approximate A for the following positions. All right, so we got a bunch of things to do here. So we need A. So we have 1/2 pi. R squared would be 1,080. And it's 1 plus the cosine of theta. So you're just plugging in different degrees. So 0 degrees. So think about it. The cosine at 0 is your x value, which is 1. So this is going to be, let's just figure out all of this because it's going to be the same in every problem. So 0.5 times pi and times 1,080 squared. All right, so that number, let's just do it backwards to make sure we did it right. 1,080 squared times pi times 0.5. Yep. This number is going to always be 183217. 6.8. And then this is 2. Cosine of 0 is 1. Put it in your calculator and figure it out. All right, 1 plus 1 is 2. So take our 18,3,217, 6.8. What is that? That's 1 million. Okay. Times 2. So the area is going to be 3664353.6 square miles. That's what this is. All right, so the area of what we see is going to be that. All right, so let's keep going. B is 180 degrees. So when the moon is 180 degrees, that means the Earth's going to be right behind it. That's a little odd. Okay, let's figure this out here. So again, use the long number. A equals 1,832,176.8 times 1 plus the cosine of 180. Cosine of 180 is going to be negative 1. 1 plus negative 1 is 0. Anything times 0 is 0. So this is all going to be 0. Well, that makes sense because at 180 degrees, the Earth is going to be directly where it can't see anything that the sun is hitting. Okay, C, 90 degrees. All right, so again, the long number times 1 plus the cosine of 90 degrees. Cosine of 90 degrees is going to be 0. So this answer is 1. So this is our approximation. Okay, and then part D, 103 degrees. All right, so put that in your calculator. Cosine of 103 degrees is negative 0.222 plus 1 gives us 0.77505. Multiply that number by 1,832,176.8, and we get 1,420,027 square miles. Okay, so this section is about using your calculator. So all you do is make sure you're in degree mode because we're dealing with degrees, and that's how you know what to use. If you have degrees, make sure you are in degree mode. So you hit the sign of 73, and that's going to be 0.9563. Okay, so that's approximately. Now the cosine of 61, again, you're in degrees. So cosine of 61 is 0.4848. And cosecant is the same as 1 over sine. So we'll do the sine of 105 degrees. And then we need to do the reciprocal of that. So 1 divided by the answer is going to give me 1.0353. And then the secant is the same thing as 1 over, this was 1 over the sine. This is 1 over the cosine. Negative 215 degrees. So do the cosine of negative 215 degrees, and then do 1 divided by that answer. So that is going to be approximately negative 1.2208. All right, let's go a little faster. So tangent 282, tangent is going to be negative 4.70463. I guess just 4 decimal places there. That's the cotangent of, let's make this bigger. Okay, let's do the cotangent of 81 degrees. Cotangent is the reciprocal of tangent, so do the tangent of negative 81, and then do 1 divided by that. So 1 divided by that answer is going to be, again, these are all approximations. I'll just write the answer down now. So negative 0.1584. Secant is the same thing as the cosine. So the cosine of 202 degrees. But it's the reciprocal, so you got to do 1 divided by that answer. So negative 1.0785. And the sine of 97, gave you an easy one, is 0.9925. Excellent. Let's go ahead and do the cotangent again. Pi over 3. Now this is radians, so now you need to be in radian mode. So if you're using a scientific calculator, hit the TRG button and go over to rad, which is radians. And then you do cotangent, so you're going to do tangent of pi divided by 3. All right. And that's 1.732, and since it's the reciprocal, 1 divided by that answer is 0.5774. Cosecant is the same as the sine, 1 over the sine. So first do the sine of 1.32, it's radians, so again, sine of 1.32, and 1 divided by that answer gives you the reciprocal. So 1.0323. And cosine, here's an easy one. So the cosine of negative 8.54, again you're in radians, is negative 0.6335. And now the tangent of 15/8. So the tangent of 15 divided by 8, and you're in radians, is negative 3.1852. Okay, so let's see here. Let's check. Okay, so this is why you check your answers. 31, if I did it again, your answer should be 4.0572. Not sure where I got the 0.5774 from. Even when I did it a second time and tried to do it incorrectly, I couldn't get the same answer, so that's a little odd. I think maybe I didn't do the reciprocal or something strange. Maybe I just missed a button. So please check all your answers. Of course, that's why you're watching this. All right, now 32a, the sine of negative 0.11. Again, it's radians, sine of negative 0.11. And that's negative 0.1098. Secant is the same thing as 1 over the cosine. So we do the cosine of 2 pi divided by 5. And then you got to do 1 divided by that answer. So that's 3.2361. And the tangent of negative 3 divided by 13. Again, these are radian measurements. Be negative 0.234, actually 50 is what it's going to be. And the cosine of 2.4 pi. Cosine 2.4 times pi. That's 0.3090. Okay, now let's do 33. All right, so sine of 30 degrees is 1/2. I don't even have to check that, but you might need to. So short leg is, you got it, now you're in degrees here, so the sine of 30 degrees and the sine of 30 they're not the same thing. Sine of 30 degrees is 1/2. So if you're doing the degrees, make sure you are in degree mode, and you'll get 1/2. But if you do the sine of 30 in radian mode, which is B, that's negative 0.9880. Okay, 30 is in radians. Remember, 180 degrees is 3.14. This is 30, so 10 times that amount. Whatever 3.14, the sine at 3.14 is, okay? So that's that answer. Let's go cosine of pi degrees. So now you got to be in degree mode, and you're going to do the cosine of pi degrees is 3.14 degrees, okay? So if you just hit pi, it's assuming that you're talking about 3.14. And since you have the degree symbol there, it's really saying the cosine of 3.14 degrees. Except we're not going to round it, we're going to use the pi button. And you do that in degree mode, you should get 0.9985. Okay, very close to 1, which if your degree is 3 degrees, you're still really close to the x-axis. So the cosine value is going to be close to 1. Versus the cosine of pi in radians. So put your calculator back in radians, and you do the cosine of pi again, and that's -1. Okay, so the cosine of 3.14 on your radian measurement puts you right here. And cosine is the x value, which the x value at that point is -1. Okay, so sine of 45 degrees. So back to degree mode. Okay, should be square root 2 over 2, or 0.7 something. So the sine of 45 is 0.7071 versus 45 radians. Again, that's 15 times whatever pi is. Okay, so now you go back to degree mode, or radian mode, and do the sine of 45, and that's 0.8509. Okay, now degree mode again. So now you go back to degrees, cosine of 3 pi over 2. 3 pi over 2 is 270 degrees. If you wanted to convert it, you could say cosine of 3 pi over cosine of 270. So I'm going to do both, all right? So cosine of 3 pi divided by 2 in degree mode is 0.9464. Now I'll do cosine of 270. 270, cosine of 270 in, degree mode. Yeah, so that should be 0. Now, why are they different? So 3 pi over 2 in degrees, that's not the same as 270 degrees, okay? If pi is 180, then 3 times 180 divided by 2 will give me 270, okay? But we're still using pi as 3.14 here. So 3 times 3.14 would be like 9. 9 divided by 2 is 4.5. Very different than 270 degrees. So again, at cosine of 4 degrees, that's very low, close to the x-axis, which is going to be almost 1, which is why we have 0.946. All right, now, again, the radian measurement of cosine of 3 pi over 2, or real close to 4.5, put it in radian measurement, and do the cosine of 3 pi divided by 2 in radian mode is 0. Very interesting for what we have there. So on the circle again, all the way around is 3.14. Well, what is 3 times pi divided by 2? That gives me 4.71. Well, where's 4.71? All the way around to 270 degrees. So the radian measurement of 3 pi over 2 is the exact same as the degree measurement at 270. All right, cool. Use the Pythagorean identities to write the expression as an integer. Okay, so on 35, tangent squared plus 1 equals secant squared. So how do we make that look like that? So tangent squared minus the secant squared, if we subtract the secant squared and then subtract the 1, we know that the tangent squared minus secant squared doesn't matter what your angle is, as long as those two are the same. Then this Pythagorean identity holds true. So 35 is -1. That's the answer. All right. So let's go to B, part B. That was A. So again, we have 4 tangent squared of beta minus 4 secant squared of beta. So these are the same. So if we divide out a 4 or factor out a 4, we get tangent squared minus secant squared, okay, equals -1. So this tangent squared minus secant squared is -1, okay? So this answer should be -4. I'm sorry. So this tangent squared minus secant squared, we already know is -1 from the last part A. So 4 times -1 is -4. So the more of these you do, the quicker you will get at manipulating, or excuse me, substituting, really is the same thing as manipulation, substituting one thing for another. All right, so 36a. What do we have? Cosecant squared minus cotangent squared. Again, as long as the angles are the same, it doesn't matter if it's theta or 3 theta or alpha or 3 alpha. Okay, so what we're looking for is cosecant squared. So out of the three identities, that's 1 plus the cotangent squared of theta equals cosecant squared of theta. All right, so what is the cosecant squared? We really want cosecant squared minus the cotangent squared. Well, let's subtract the cotangent squared over there. And we get cosecant squared minus cotangent squared equals 1. So this answer should be 1. That's 36a. All right, so let's go to B. And it's the same thing as number 35. We factor out a 3, we get the cosecant squared minus the cotangent squared. And we just figured out that that's the same thing as 1. So 3 times 1 is 3. That would be the answer to 36b. All right, 37. Let's factor out a 5, and we get sine squared plus cosine squared. Well, sine squared plus cosine squared, if you look at your identities, is 1. So that's 1. 5 times 1 is 5. That would be your answer. Part B. Again, as long as your angles are the same, then you just treat it as if it was just theta by itself. So we factor out a 5 again, it's going to be the same thing as this last one. So 5 times 1 is still going to be 5. Okay, so the more problems we do, the trickier they're going to become. And there's quite a few of these. So let's go ahead and keep doing these things. So 38a is secant squared minus tangent squared. So if you look at your Pythagorean identities, we should use the 1 plus tangent squared equals secant squared, okay? And how do we make those look the same? By subtracting the tangent squared over. And again, your angles are the same, so just disregard them. So what do we have? Secant squared minus tangent squared is 1. So if we factored out that 7, okay, then it's 7 times 1, or 7. 7 would be the answer. All right, that's A. Now B, again, you have secant squared minus tangent squared. It's the exact same thing. As long as the angles are the same, it doesn't matter. Factor out a 7, it's going to be 7 times 1 again, because you'll have secant squared minus tangent squared. So the answers for both A and B are 7. Okay, so don't let fractions fool you, but you have to be good at factoring. Been telling you this all of high school. If you're not good at factoring, you probably can't recognize certain things. Well, this is the sum of cubes. If you have to look it up, look it up. Sum of cubes says, the first parentheses, it would be the numerator. You take the cubed root of each one, so that's sine plus cosine, okay, which happens to be what is in your denominator. And then you have the other part of your factoring cubes, which would be the first squared, the last squared, and minus the 2 multiplied together, sine, cosine. Okay, so if that's a plus, then the minus is in the second position. 1, 2, 3. So what do we have here? The sine plus cosine reduces with the sine plus cosine. And we have sine squared minus sine cosine plus cosine squared. Well, what is sine squared plus cosine squared? That's 1. So this is 1 minus the sine cosine. So all you've done is simplify the expression, and that is your answer. Again, you have to try and keep working at this. There's nothing here that you couldn't do, but you probably forgot about the sum of cubes. Well, let this be your wake-up call. Watch for it. All right? Look at number 40. Okay, you have the difference of cubes on the bottom. So again, on top, sine minus cosine. On the bottom would be sine minus cosine. The cubed root of both of those with the minus sign. Since the minus sign's there, it's first, and the rest is pluses. So square the first, square the second, and multiply the two together. You got to remember it. So sine minus cosine, whoops, can't do that yet. Yeah, I can. That reduces, so we have 1 over, and again, the sine squared plus cosine squared is 1. All right, and that's simplified. You're all done. We can go a little further if we wanted to, but eventually you get to the point where you work yourself back in a circle and get what you started with. Okay, next one, 41. Okay, 9 minus tangent squared and tangent squared minus 5 tangent theta plus 6. Okay, so in the denominator here, we have a trinomial. So look at it this way, x squared minus 5x plus 6. If we say let x equal tangent, okay, now this factors into x minus 3, x minus 2. So let's change the way that looks here in a second. But look up here. What if I said that was 9 minus x squared? That's the difference of perfect squares. And again, I said let x equal tangent. So that factors into 3 minus x, 3 plus x. All right, so if we put tangent back in for x and rewrite this, we get 3 minus the tangent, 3 plus the tangent. This is in your numerator. On the bottom, you have the tangent minus 3 and the tangent minus 2. Okay, so you look at that and say, well, nothing cancels out. Like, no, nothing cancels out, except I can take a negative out of this, and if I took a negative 1 out, that would change the tangent to a negative and the 3 to a positive. And therefore, those would be canceled out or reduced out. You still have a negative 1 there. And then you have 3 plus tangent over the tangent minus 2. Okay? But we probably should distribute the minus sign through here. So we get 3 plus the tangent all over the 2 becomes positive and the tangent negative. And that would be, I think, what your answer is, and that is true. All right, 42. So now we have cotangent. Look, it's the same type of problem, so you try it. So let's let x equal the cotangent. And rewrite it, factor it, and then come back to this and see if you can simplify it. All right, so I have x squared minus 4 over x squared minus x minus 6. Difference is squares, x minus 2, x plus 2. And this is x minus 3, x plus 2. Those will reduce out even before I put the cotangent back in. I don't have to put the cotangent in until I'm done simplifying. So you can do the same thing. All right, so now if we put the cotangent back in, that's the cotangent minus 2 all over the cotangent minus 3. And that is the actual answer. It's not that difficult. You can do this. All right, 43. 2 minus the tangent of theta. That doesn't do anything for me. 2 cosecant of theta minus secant of theta. All right, so what we're doing here is probably, since there's no squares, we're probably not going to use the Pythagorean identities yet. Let's use the tangent and cotangent identities and the sine and cosine, cotangent reciprocal identities. So here's what I mean. 2 minus, the tangent of theta is the same thing as sine over cosine. And the cosecant is 1 over the sine. And the secant is 1 over the cosine. Okay, so let's take this a little bit, one step further. 2 over 1 minus the sine over cosine. That's the numerator, and I have 2 over the sine minus 1 over the cosine in the denominator. Okay, now, we need a common denominator in the numerator and a common denominator in the denominator. So basically, you just cross multiply. I'm going to multiply by cosine over cosine, and I get 2 cosine minus the sine all over the cosine. That's my numerator. In the denominator, I need a cosine here, and I need a sine here. So in the denominator, I have 2 cosine minus the sine, That looks familiar. All over sine cosine. And what you're supposed to do is take the numerator, 2 cosine minus sine, all over the cosine, times the reciprocal of your denominator, sine cosine, all over 2 cosine minus sine. And your denominators reduce out. And this cosine reduces with that cosine. So the answer is just the sine of theta. Okay, number 44. Again, you try it. Change cosecant, which is 1 over sine. Let's just do the numerator so far. So we need a common denominator, which is obviously the sine. 1 over sine plus sine over sine. So my numerator is 1 plus the sine of theta all over the sine of theta. Now let's do the denominator. 1 over the sine squared of theta. Okay, so you treat it just as if it was sine, okay? So 1 over the sine is the same as cosecant, but let's leave it as 1 over the sine squared. All right, and you have cosecant, which is 1 over sine. So what's your common denominator? That would be sine squared. So let's multiply the right side by sine over sine. And we get 1 plus the sine all over sine squared. Now that's our denominator. So when you have a fraction divided by another fraction, it's the top times the reciprocal. So this would be sine squared over 1 plus the sine. And look at that. Your numerators reduce out, and one of these signs reduces with one of those, leaving the sine of theta as your answer. Crazy. All right, so writing one in terms of the other. So basically what this means is you've used the cotangent identities, and so the cotangent identity is this, 1 plus the cotangent squared of theta equals the cosecant squared, all right? So that's how you start. And now the second thing is we have to solve for the cotangent. So cotangent squared equals the cosecant squared minus 1. And we take the square root to make the cotangent squared just the cotangent. And we get the square root of the cosecant squared minus 1. Okay, so the cosecant squared minus 1, we need it in terms of sine now. So cosecant is the same thing as the sine, 1 over sine. So this is 1 over sine squared minus 1. But you can't leave it like that. If you have a fraction inside of there, you need to go ahead and get a common denominator and see what happens. Okay? Okay, so again, this is all under the radical. Don't forget the radical. Sine squared minus sine squared over sine squared. 1 is the same thing over itself. So we have 1 minus the sine squared all over sine squared. Well, I can take the square root of the bottom if I can. So that's going to be 1 minus the sine squared, and the square root of sine squared on the bottom is sine. Now, what is 1 minus sine squared? Well, cosine squared plus sine squared equals 1. If I move the sine squared over, I get cosine squared. So I have the square root of cosine squared all over sine squared. The square root of cosine squared is cosine over sine squared. But you're not done. Cosine over sine times 1 over the sine, because sine squared can be written like that. Cosine over sine is cotangent. So we have cotangent, over, times 1 over sine, or cotangent over sine. Now this is where you get into the problem, is you start to work the problem backwards. If you look in the back of the book, let's see, where is it? This should be the answer. Okay, the square root of 1 minus sine squared over sine squared. Or really the better answer. The better answer is this one right here. The square root of 1 minus sine squared in the numerator all over sine. Because you had 1 minus sine squared over 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 1 to put it in terms of sine only. So once I introduced the cotangent, I defeated what it was doing. All right, so let's go on to 46 and try to do the same thing. Now we have tangent theta, so only use the tangent identity. So 1 plus the tangent squared equals secant squared. And now solve for tangent. Okay, so tangent squared equals secant squared minus 1. Take the square root, and the tangent is the square root of secant squared minus 1. Now we need it in terms of cosine, and that is 1 over the cosine squared minus 1. So you need a common denominator, so cosine squared over cosine squared, that's 1. And again, this answer is going to be 1 minus the cosine squared over the cosine squared. But you should take the square root of that bottom one. So you have 1 minus the cosine squared all over cosine. That should be the answer. Okay. If you kept going, again, 1 minus cosine squared is sine squared. And the square root of sine squared is sine. And the sine over cosine is tangent, which is how we started. Okay, we didn't want that. All right. So that's how you know you're going too far, once you go past the ones you want. All right, 47, secant. So we use our secant Pythagorean identities. 1 plus the tangent squared equals secant squared. So we solve for secant, and we get 1 plus the tangent squared, square root. Now it needs to be terms of sine. So secant goes with the cosine, so that doesn't help us, but tangent is the same thing as sine squared over cosine squared. Okay, so now we get a common denominator. Cosine squared over cosine squared is 1. Sine squared over cosine squared. Okay, put those together. I get cosine squared plus sine squared. There's an identity right there. And cosine squared plus sine squared is 1. The square root of 1 is 1. And the square root of cosine squared is cosine. Equals a secant, which is what we said. But we wanted this in terms of sine. And as you can see, we went into a circle here. So instead of using the Pythagorean identities, let's go back and let's just use the identity. The secant of theta is the same thing as 1 over the cosine of theta. And cosine squared plus sine squared equals 1. And cosine squared equals 1 minus the sine squared, if you subtract that over. And you take the square root. Now all of a sudden you have what the cosine equals. So here we have 1 over the square root of 1 minus the sine squared of theta. And this would be your answer, I think, if you look in the back of the book. Yes, it is. Okay? So there it's all in terms of sine, and you're done. So sometimes you try the Pythagorean identities because mostly that's what we want. So let's try the same thing on 48. Let's not use the Pythagorean identities. Let's just use the normal reciprocal identities. So again, you look at cosecant. That's the same thing as 1 over the sine. And how we change that to cosine. The exact same thing is what we have here. If we moved the cosine squared over instead, we'd have sine squared equals 1 minus the cosine squared, square root. So this answer is really 1 over the square root of 1 minus the cosine squared. So now, cosecant is written in terms of cosine. All right, same thing. Sine is the same thing as 1 over the cosecant. All right, so what do we know about cosecants and secants? Well, the 1 over the cosecant isn't really helping us at the moment. You could do the Pythagorean identities and work through them. You still get the same answer, but it's going to take you a little bit longer. Let's try sine squared plus cosine squared. There's only 2 ways to go about doing these problems. All right, so we solve for sine, and we get 1 minus the sine squared. 1 minus the cosine squared, and take the square root. That's the sine. All right, so 1 minus cosine squared. Well, cosine is the same thing as the secant, the reciprocal. So this is 1 minus 1 over the secant squared. All right, get a common denominator. So secant squared over secant squared minus 1 over secant squared. And what do we get? We get secant squared minus 1 all over secant squared. Or the final answer, secant squared minus 1 all over the secant. Okay? Okay, so on this one, again, we're going to start with the Pythagorean identity and isolate the cosine. So 1 minus the sine squared, but notice you have to take the square root to get rid of the cosine squared. Now, sine squared is the same thing as 1 over the cosecant squared. Okay? And the cosecant squared is equal to 1 plus the cotangent squared identity. So there's where we're going to get our cotangent. So the question is, how do we do this now? So cosine equals, 1 minus, instead of saying sine squared, we're going to do the identity, which is 1 over cosecant squared. And cosecant squared, let's replace that. 1 minus 1 over 1 plus the cotangent squared. All right, so we need a common denominator, so this 1 here is going to change into 1 plus cotangent squared over 1 plus cotangent squared. So they all have the same common denominator, and technically, you just wrote cosine in terms of cotangent. All right, and you have this 1 minus 1, those cancel out. So what do we have here? We have the cotangent squared over 1 plus the cotangent squared. This is all under the radical. We can take the square root of cotangent squared and get cotangent. And we're still left with 1 plus the cotangent squared in the denominator under the radical. Okay, and that should be the answer. Verify the identity by transforming the left-hand side into the right-hand side. And you could go back and forth. Now, we're setting you up to do both for longer equations, so let's just do the left-hand side. All right, why does cosine of theta times the secant of theta equal 1? Well, secant of theta is the same thing as 1 over the cosine of theta. That's why they equal 1. The cosines reduce out, so you get 1 over 1, which equals 1. All right, tangent and cotangent. All right, so tangent is the same thing as the sine over cosine, and the cotangent is the same thing as cosine over sine. And so there you see how that equals 1. They reduce to 1. Okay, sine and secant. Again, secant goes with cosine, so we have sine times 1 over cosine, which gives us sine over cosine, which is the tangent. So very cool. 54. Cotangent is the same thing as cosine over sine, which those reduce out, leaving just cosine as the answer. 55. Cosecant and secant. Let's rewrite those with their reciprocal identities. That's 1 over the sine. And secant goes with 1 over cosine. The top times the reciprocal of the bottom gives us cosine over sine, which is the cotangent of theta. Cotangent and secant. Cotangent is cosine over sine, and the secant is 1 over cosine. So that's 1 over sine, which is the same thing as the cosecant of theta. All right, now we have left and right side. 1 plus the cosine of 2 theta, 1 minus the cosine of 2 theta. So what you need to realize here is this is a plus b times a minus b. That's the difference of squares, which is a squared minus b squared. All right, that's what a squared minus b squared equals. So if I said x squared minus 9, that factors into x minus 3x plus 3. So you have to recognize that. Again, if you can't recognize these things, then you can't do the problem. Okay, so what do we have here? This is the first thing squared, which is 1, the minus sign, and the second thing squared, cosine squared of 2 theta. And that's supposed to equal sine squared of 2 theta. And that's true, because 1 minus cosine squared of 2 theta is sine squared of 2 theta. So that you were done at that point. The left side equals the right side. Okay, so you have the difference of squares here, and you could factor that. And as you do that, you'll see that it doesn't match the right side. But we have like terms that need to be put together. So let's go ahead and subtract 2 of those things. So here's what it looks like. X squared minus y squared equals 2x squared minus 1, if you like the algebra part. So I'm going to put my x squared together. I'm going to subtract 2x squared over there, except it's 2 cosine squared. So you have a 1 cosine squared, okay, minus the 2 cosine squared. So 1 minus 2 is negative 1 cosine squared of 2 theta. You still have the minus sine squared of 2 theta equals, and you still have a negative 1 on the right side. Everything's negative. It doesn't matter if it's all negative. If you want to change all the signs, just multiply everything by negative 1 and watch what happens. You get the cosine squared plus sine squared equals 1. And of course it does. That's 1. Doesn't that equal 1? So you're done. 59. Okay, secant squared of theta minus 1 is the same thing as tangent squared of theta. All right, and tangent squared is the same thing as sine squared over cosine squared. Those reduce out, leaving sine squared, which is what it's supposed to equal. Okay, secant squared of theta. If I distribute this, I get tangent squared of theta plus cotangent times the tangent. These are all of theta. I'm going to leave the thetas out. And cotangent times tangent, that's the same thing as cosine over sine. And tangent is sine over cosine. That's the same as 1. So what we have on the left side is tangent squared plus 1 equals secant squared. And that's your identity. Tangent squared plus 1 is the secant squared. So yes, they do equal. 61. Again, you're just doing the best you can. All of the thetas or the angles and everything are the same. So I'm just going to leave those off. So we have sine, and cosecant is the same thing as 1 over sine. And cosine over secant, secant is the same thing as 1 over cosine. Well, you have a fraction inside of a fraction. So you take the top times the reciprocal of the bottom, take the top times the reciprocal of the bottom, and what do we have? Sine squared plus cosine squared equals 1. And that's true. Sine squared plus cosine squared is 1. They match. Okay, 1 minus 2 sine squared equals 2 cosine squared minus 1. All right, so we can simplify both sides or one side. It doesn't matter. 1 minus the sine squared. So sine squared plus cosine squared equals 1, just to review the identities. Sine squared is the same thing as 1 minus the cosine squared. Okay, so we're going to substitute 1 minus cosine squared for the sine squared. Distribute the negative with it. So 1 minus 2 plus 2 cosine squared is equal to 2 cosine squared minus 1 on the right side. 1 minus 2 is negative 1. Okay, so here we have 2 cosine squared and 2 cosine squared. Aren't these the same? This is a negative 1, next to negative 1. So yeah, that's the same. So we just rearrange these to put the positive 1 first, and they match. Here we have the difference of squares. So a plus b, a minus b is the same thing as a squared minus b squared. So 1 minus sine squared. That's the same thing as cosine squared. Cosine squared is 1 over secant squared. Check. Okay, 64. 1 minus sine squared. We've already learned. See, if you've been doing this, it should be getting familiar. But if you don't work through this, you're going to fail the assessments. Force yourself to see the similarities in every problem or every other problem. All right, so 1 minus sine squared is cosine squared. 1 plus tangent squared is the same thing as secant squared. All right, so secant is the same thing as 1 over the cosine squared. Okay, that's why we have 1 equals 1. Check. 65. Okay, secant theta minus cosine of theta. I don't see any squares here. It's not that we can't put square roots in, but when there's not squares, let's think about the reciprocal identities. The secant of theta is 1 over the cosine of theta. Oops, minus cosine of theta. All right, so let's just do the left side first here. Let's get a common denominator by multiplying by the cosine of theta. So 1 minus the cosine squared of theta all over the cosine. Well, 1 minus cosine squared is sine squared. Okay, and if we split the sine up, sine and sine over cosine, we can say that's sine over cosine times the sine over 1. Sine over cosine is the tangent times the sine. And that's what we have. Same type of thing. Cosecant is the same as 1 over the sine. Okay, let's get the same thing. Common denominator multiplied by sine over sine. 1 minus sine squared over the sine. That's cosine squared over the sine. Cosine squared is cosine times cosine all over sine. There's your cotangent times the cosine. Check. All right, sine of theta plus cosine of theta all over sine of theta. Put the sine, the denominator, underneath each one. So sine of theta over sine of theta is 1, and cosine over sine, that's cotangent. So this is 1 plus cotangent. Check. Notice that the evens go hand in hand with the odds. Let's put the denominator under each one. That's sine over cosine plus cosine over cosine. That's tangent plus 1. Check. All right. Cotangent, let's just change all these to the reciprocal identities on the left side and see what we get. Cosine over sine. Cosecant goes with sine. So this is cosine plus 1 over sine. And the tangent is sine over cosine minus the sine. And we need to get common denominator, so multiply by cosine. So here we get sine minus sine cosine all over cosine. If we multiply these together, first of all, it can get a little messy. So sine minus, you may have gone a different direction than this. Sometimes when you're manipulating, we have a lot of things we can change them into. Okay, let's go with, I want to factor out a sine there, see if that works. And we're multiplying again, remember? So factor out a sine, I get 1 minus cosine. So the sines, since it's multiplication, is going to be, they're going to reduce out. So now I have a plus b times a minus b. That's a squared minus b squared. So at the top I have, of course I have to rearrange this here. If we do this first, let me rewrite it. 1 plus the cosine of theta times 1 minus the cosine of theta all over the cosine of theta. All right, so now this is the difference of squares on the top, so it's 1 minus cosine squared all over cosine. Let's put cosine underneath each thing, and we get 1 over cosine minus cosine squared over cosine. 1 over cosine is the same thing as secant, and one of these cancels with one of those, leaving just 1 left. Check. Okay, same type of thing. Just start changing. You could change both at the same time. I'll go ahead and change both of these at the same time and see if we can get them to meet. Cotangents, cosine over sine, plus sine over cosine. On the right side, this is 1 over sine, and secant is 1 over cosine. Okay, you need a common denominator on the left, so we're going to multiply this one by cosine over cosine, and this one by sine over sine. So we have cosine squared plus sine squared all over cosine times sine. On the right side, we have 1 over sine times cosine. Well, cosine squared plus sine squared is 1. So these two are the same thing. All right, again, we'll try to do them, both of them at the same time here. Secant squared is 1 over the cosine squared. Cosecant is 1 over sine. Okay, on the right side, we have 1 over the cosine squared, and cosecant is 1 over the sine squared. All right, so this is plus, and the other side is multiplication. All right, so 1 over cosine squared, sine squared. And we need a common denominator here, so multiply this by cosine squared over cosine squared. This one by sine squared over sine squared. We have sine squared on the top plus cosine squared, all over sine squared cosine squared. And sine squared plus cosine squared is 1. And they match. Okay, let's get started on 72. Okay, multiple ways we could go about doing this. Excuse me. So everything is 3 theta. So we're going to just disregard the 3 theta and try to manipulate these. All right, so on the right side, cosecant of theta goes with sine. So this is 2 over the sine squared minus 1. Okay, so if we get a common denominator, that's sine squared over sine squared. So this would be 2 minus sine squared over sine squared. Okay, and that matches our denominator, but the top is different. Well, what do we know about sine squared? So cosine squared plus sine squared equals 1. So sine squared is the same thing as 1 minus cosine squared. Okay, so I'm going to change the minus, the sine squared to 1 minus cosine squared, and distribute the negative. 2 minus 1 is 1, and and then we have a plus cosine squared all over the sine squared, which is what we have here. So check. You're just distributing the minus sign, not the 2 in this position over here. All right, let's go on. Okay. The log of cosecant of theta is the same thing as the log of 1 over the sine of theta. Okay. And anytime you have the fraction, that's the log of 1 minus the log of sine of theta. And here you have the minus log sine of theta. Well, what's the log of 1? Log of 1 is 0 minus log of sine. That's just going to be the exact same thing. So check, it's done. 74. Okay, so left side is log of sine over cosine, which again, that's the same thing as the log of sine, minus the log of cosine, which that's what we have. Check. Find the exact values of the 6 trigonometric functions of theta if theta is in the standard position and p is on the terminal side. All right, so what is that? P is on the terminal side at 12, negative 5. So we're at 12 and negative 5 right there. Okay, so that goes all the way around to here. Boom. All right, so now what do we have here? That's negative 5, that's 12. What is the radius here? So we just do the Pythagorean theorem. So 12 squared plus negative 5 squared, which is going to be positive, equals the r squared. 144 plus 25 is 169, and the square root of that is 13. All right, so now that we have our right triangle, we can do our 6 trig functions. So sine, cosine, and tangent. The sine of theta is equal to the opposite leg over the hypotenuse. And so the cosecant is the reciprocal, cosecant is the reciprocal of that, negative 13 over 5. Cosine of theta is the adjacent over hypotenuse, so the secant of theta is 13 over 12. And the tangent of theta is opposite over adjacent. And the cotangent then is the reciprocal of that, negative 12 over 5. All right, let's clean that up, and then we'll do number 76. All right, 76, negative 8, and negative 15. We're in the third quadrant. Negative 8, and down negative 15. So that's an angle. So if we just drop that down, so we have negative 15 here and negative 8 there. So what is R? Okay, so negative 8 squared plus negative 15 squared equals R squared. So 64 plus 225 equals R squared. That's 289, and the square root of that is 17. And the radius is always, 17, not 12. Radius is always positive. Okay, now again, what do we have? Sine of theta is the opposite leg over the hypotenuse, negative 15 17ths, so the cosecant is negative 17 over 15. Cosine of theta is the adjacent leg, negative 8, over the radius, over the hypotenuse, so the secant is negative 17 over 8. I always put my negatives in my numerator. Tangent theta is opposite leg, negative 15 over adjacent leg, negative 8, or positive 15 eighths. So the cotangent is positive 8 fifteenths. All right, so we're at negative 2, negative 5. Negative 2 and negative 5. So all the way around, there's your right triangle. So we use our Pythagorean theorem. Negative 2 squared plus negative 5 squared equals R squared. So 4 plus 25 is 29. So R is the square root of 29. So sine of theta is opposite leg over hypotenuse, negative 5 over the square root of 29. So just leave them in these positions for now. Cosecant is square root of 29 over negative 5. And the cosine is the adjacent leg, negative 2. Negative 2 over the square root of 29. And so the secant is the reciprocal, square root of 29 over negative 2. Tangent is opposite leg over adjacent leg, or positive 5/2. And the cotangent is 2/5. Now let's clean this up, and we'll do 78. P is at 2, 3. 1, 2, 1, 2, 3. Let's do that again. Make it a little nicer. Oops. One, two, 1, 2, 3. So there is our triangle. So, negative 2, 3, sorry. That's over here. Negative 2, positive 3. So that's wrong. Negative 2, positive 3. So negative 2 squared plus 3 squared equals your radius squared. So 4 plus 9. So the square root of 13 is R. Sine of theta is opposite leg over hypotenuse. So the cosecant is the reciprocal. Cosine is the adjacent leg over hypotenuse. Secant is the reciprocal. And the tangent, opposite leg over adjacent. And the cotangent is the reciprocal. Find the exact values of the 6 trigonometric functions in the specified quadrant. Okay, so you're just thinking about this. So y equals negative 3x plus b. Y equals mx plus b. So here's what that looks like. So your slope is negative 3, down 3 over 1. Boom. And so you're in the second quadrant. So this line continues, remember? So 1, 2, 3, up 3, and over 1. So we're in the second quadrant, which is here. So this is what we're looking at. So this is -1 and +3. So just to draw it a little bit bigger, -1, +3, got to find r. And then we just go through the exact same process again. Okay, so -1 squared plus 3 squared equals r squared. 1 plus 9 is 10, so r is the square root of 10. All right, sine of theta is opposite over hypotenuse. Cosecant is the reciprocal. Cosine is the adjacent over hypotenuse. Secant is the opposite or reciprocal, so that'd be the negative square root of 10. Tangent is opposite over adjacent, which is just -3, and so the cotangent is -1/3. Fourth quadrant. So let's solve for y. Oops, sorry, let's move that over. 3y equals -5x plus 0 divided by 3. So y equals -5/3 x plus 0. So we go down 5. 1, 2, 3, 4, 5. Goes through at 0. And over 3. 1, 2, 3. Gosh, this is so backwards. Yeah, rise over run. Down 5 and over 3. All right, and we're in the fourth quadrant, so this is where it's at. There's our triangle. +3 and -5. Now we've got to find r. 3 squared plus -5 squared equals r squared. 9 plus 25 is 34. So r is the square root of 34. Okay, so the sine of theta opposite over hypotenuse. So the cosecant, reciprocal. Cosine is adjacent over hypotenuse. Secant is the reciprocal. Tangent is opposite over adjacent, and cotangent is its reciprocal, -3/5. And the fourth quadrant again. Slope is -3/4. All right. So down 3 and over 4. 1, 2, 3, 4. There you go. So this goes all the way out of there. So this is +4, -3, and r. -3 squared plus 4 squared equals r squared. 9 plus 16 is 25. So r is 5. Sine of theta is equal to opposite leg over hypotenuse. Cosecant is -5/3. Cosine is the adjacent leg over hypotenuse. Secant is reciprocal. Tangent, opposite leg over adjacent, and cotangent is the reciprocal. Bisects the quadrant. So you're bisecting quadrant 3. Bisecting means angle bisector. So this is 45-degree angle. So -2, +2. You could use -1 and +1, or excuse me, -2 and -2, or -1, -1, or -3, -3. It doesn't really matter. So what's r then? Okay. All right. So you have -2 squared. I just used -2. You could use anything you wanted. -2 squared. R squared, so 4 plus 4 is r squared. Square root of 8 is r. So that's square root of 4 times square root of 2, or 2 square root of 2. All right. So that's theta. So the sine of theta is equal to the opposite leg over hypotenuse, which is -1 over the square root of 2. Okay, which if you rationalize that, that gives you the negative square root of 2 over 2 for the y value, which is what sine is. Cosecant is the reciprocal, negative square root of 2. Cosine, again, is negative 2 over the hypotenuse, 2 square root of 2. Again, they should be the exact same, cosine and sine. So it's going to be negative 1 over square root of 2. The secant is the reciprocal, so negative square root of 2. And the tangent is sine over cosine, so anything over itself is 1. Cotangent is going to be 1 as well. Parallel to the line. All right, so we got to figure this out. Subtract 2, add 7x, divide everything by 2. So y equals 7 halves x plus, minus 1. Parallel to this line. All right, so let's draw this line. Goes through at negative 1, goes up 7. Let's add some grid lines to this. Okay, so let's put negative 1 where it should. Oops, why did that do that? Negative 1 right here. And we go up 7. 1, 2, 3, 4, 5, 6, 7. And over 2. 1, 2. Now it's parallel to this. So if it's parallel to this, we just have it going through at 0. I'll do this in a different color. Going through at 0. And you still go up 7 halves. 1, 2, 3, 4, 5, 6, 7. One more. And over 2. Boom. All right, so what do we really have here for our triangle? It's up 7, and it's over 2. So what's r? 2 squared plus 7 squared equals r squared. 4 plus 49 is r squared. 53 equals r squared, so the square root of 53. All right, sine of theta, opposite leg over the hypotenuse. Okay, so the cosecant is the square root of 53 over 7. Cosine, adjacent leg over the hypotenuse. Secant is a reciprocal. Tangent, opposite leg over adjacent, and the cotangent is the reciprocal. Parallel to the line. All right, so now we got to make the line. Y equals mx plus b. So slope is 6 minus negative 2 over 1 minus 3. That's 8 over negative 2 or negative 4. Y equals negative 4x plus b. We need b, so we need to have an x and a y. We can use either one of these two. I'll use a. Y is 6, x is 1. 6 equals negative 4 plus b. Add 4, you get 10. All right, so here is our problem here. I'm going to change this again. All right, it's not letting me do it, so I'll just go by 2s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the slope is negative 4, so down 4. 1, 2, 3, 4. And over 1. Down 4 more. 1, 2, 3, 4, and over 1. So that's parallel to this. All I need really is the slope. The slope is negative 4. So, again, it starts at 0 and goes down 4. 1, 2, 3, 4, and over 1. 1, 2, 3, 4, over 1. It says it's in the second quadrant, so this here is in the fourth quadrant. So we go the other way. 1, 2, 3, 4, over 1, 4 over 1, and there you have it. So what do we have there? 2, 4, 6, 8, and negative 2 at the bottom there. What's r? So negative 2 squared plus 8 squared is equal to r squared. 4 plus 64, that's 68. Square root of 68. 68 goes 4 and 17. So 2 square root of 17 is r. All right, sine of theta is going to be opposite leg over hypotenuse. 2 square root of 17, which is 4 over the square root of 17. So the cosecant is the reciprocal, square root of 17 over 4. Cosine is the adjacent, negative 2. Sorry, that was, negative 2 over the hypotenuse, 2 square root of 17. So this is negative 1 over the square root of 17. So the secant is just negative square root of 17, the reciprocal. Tangent is opposite over adjacent, or negative 4, and the cotangent would be negative 1/4. Find the exact values of the 6 trigonometric functions of each angle. So 90 degrees. So 85A, you're at 90 degrees around your unit circle here. That's 0, 1. So R is 1, Y is 1, and X is 0. So that's where we have all of our values. Remember, this is your radius. So the sine of theta is equal to the opposite leg. Well, the opposite leg here is going to be the radius, going to be y over the hypotenuse 1. So 1 over 1 is 1. So the cosecant is 1. Now the cosine is x over the hypotenuse. X is 0 over the hypotenuse of 1. So that's just 0. But the secant would be 1 over 0, or undefined. Okay, and then tangent is y over x, which is 1 over 0, and again, that's undefined. And we'll just use this as undefined. Cotangent, though, is 0 over 1, or 0. Okay, so for 0 on the unit circle, we are right here. So the x value is 1, the hypotenuse is 1, but the y value is 0. Hence, 1, 0 for the coordinate. So sine of theta is the opposite, which is 0, over the hypotenuse, 1. So the sine is 0. The cosecant is going to be undefined because it's 1 over 0. Now the cosine is the adjacent leg, which is 1 over the hypotenuse, 1, or 1. So the secant is going to be 1 as well. Tangent is going to be y over x, which is 0. And that means the cotangent is going to be undefined. All right, let's erase that and do 7 pi over 2. All right, 7 pi over 2. Where is 7 pi over 2? Well, 1 pi over 2, 2 pi over 2, 3, 4, 5, 6, 7 pi over 2. All right, 7 90s. Well, okay, so what is that coordinate? That coordinate is 0, negative 1. Okay, so the sine of theta is going to be the opposite leg, be negative 1. Opposite leg would be, negative 1 over the hypotenuse of 1. All right, so to give you an understanding, here is the opposite leg and the adjacent leg. And we keep getting further, the adjacent leg and the opposite leg. The opposite leg is getting longer, okay, all the way to 7 pi over 2. So the opposite leg is going to be the negative 1. All right, its opposite leg is y. All right, so the cosecant is the reciprocal, or negative 1. The cosine is the adjacent leg, which it's getting closer and closer to 0. So 0 over the hypotenuse. And the secant then is undefined because it'd be 1 over 0. And tangent is y, negative 1, over x, 0. That's undefined. Cotangent is going to be the reciprocal, 0. All right, let's erase that and do D. All right, 3 pi. We know where 3 pi is. Odd pi's are right here. So negative 1, 0. And again, the adjacent leg is the x, and the opposite leg is your y, which is 0. So adjacent leg and opposite leg. So sine is going to be opposite leg over hypotenuse, 1, or 0. Cosecant is going to be undefined, 1 over 0. Cosine is the adjacent leg, negative 1 over the hypotenuse, 1. And the secant will be the same thing, but reciprocal, still negative 1. And the tangent is going to be y over x, which is 0 over negative 1, or 0. And the cotangent is going to be undefined. Let me see here, which was A. Okay, same thing here, 86. You're at 180 degrees, which is the exact same thing as D on the last problem. So I'm not going to do that one. negative 90 degrees, that's going to be down here at 7 pi over 2, which is the same as 85. You can rewind this a little bit and see it. 2 pi is going to be at 0, which is the same as going to be b from the last problem. And 5 pi over 2, 1, 2, 3, 4, 5, that's going to be at 90. A on the last problem. So I'm not going to bother doing those. All right, so let's go on. 87. Now, find the quadrant containing theta. All right, so A is cosine. Cosine is your x value. Where is the x value greater than 0? All right, so let's just do this down here. X is greater than 0 in the first and fourth quadrant. And then it has sine, which is y. Y is less than 0, so y is negative. So where is y negative and x positive? The fourth quadrant. All right. B, the y value is negative. Cotangent is x over y, which is positive. All right. So for a fraction to be positive, both of them are negative or both of them are positive. So since we already know that y is negative, that means they both have to be negative. And where are they both negative? In the third quadrant. Cosecant is the same as 1 over sine, so it's the y value. Y value is positive. Secant is the x value, and x is negative. Where is x negative and y positive? X is negative and y is positive in the second quadrant. And D, secant goes with cosine, so that's x. X is negative, and tangent is y over x. So again, for it to be positive, that means that both are positive or both are negative. And since x is negative, that means they both have to be negative, and we are in the third quadrant. All right, again, you do this, pause it, and then come back to me and listen to what I told you. Tangent is y over x. It's negative. So one's positive and one's negative. And then you have the second part here, x is positive. So if x is positive, that means y has to be negative. All right, so if x is positive and y is negative, we are in the fourth quadrant. Part B, secant goes with cosine. That's the x value. It's positive. Tangent is y over x. It's negative. So that means one's positive and one's negative. And since x is positive, y has to be negative. So if x is positive and y is negative, you are again in the fourth quadrant. All right, C, cosecant is the 1 over sine, so that's y. Y is positive. Cotangent is x over y. So for that to be negative, one has to be positive and one is negative. So since y is positive, x is negative. If x is negative and y is positive, you are in the second quadrant. And D, cosine is x. X is negative. Cosecant is 1 over the sine, so that's y. Where is x negative and y negative? That would be the third quadrant. All right, use fundamental identities to find the values of the trigonometric functions for the given conditions. Okay, so tangent is y over x, and we are at negative 3 over 4. Now, we don't know where the negative's at. It's either on the y or the x, but then we have this. Y is positive, so that means the negative has to be on the 4. So y is positive, and x is negative 4. So where are we? So y is positive, x is negative. We are over here. So y is positive 3, 1, 2, 3, and x is negative 4, 1, 2, 3, 4. So drop down in altitude, that's theta. We want to know negative 4 and 3. What is r? And we've got to find the rest of the trigonometric values. Okay? All right, so this is your typical 3, 4, 5 triangle. All right? As long as the 3 and 4 are the legs, then the hypotenuse has to be 5. Okay, so what do we have? We already have sine. Or no, I'm sorry. We have tangent. The sine is going to be opposite over hypotenuse. And so that means the cosecant is 5/3. And the cosine is going to be adjacent, negative 4 over the hypotenuse. And the secant is negative 5/4. Tangent we already have is negative 3/4, but we know the negative's on the 4, and it doesn't really matter. Cotangent is negative 4/3. All right, moving on. Right, cotangent is 3/4, so that's x over y. They're both positive or they're both negative. And there we see that x is negative, so they both must be negative. We are in the third quadrant, where x is negative 3, 1, 2, 3, and y is negative 4, 1, 2, 3, 4. And again, it's a 3, 4, 5 triangle. Radius and hypotenuse are always positive, so the sine is the opposite, sine of theta, opposite leg over hypotenuse. So the cosecant is the reciprocal, and the cosine is going to be the adjacent leg over the hypotenuse, and the secant is going to be the reciprocal. And we already have the cotangent, so the tangent is 4/3, and the cotangent is our given 3/4. All right, sine is negative 5/13, we're not sure where the negative is at, but remember, the sine is y over the hypotenuse, and the secant goes with cosine. So that means x is positive. All right, x is positive, and the hypotenuse, or the radius, is always positive, so y must be negative. All right, if x is positive and y is negative, we are in the fourth quadrant. All right, so that means y is negative 5, radius or hypotenuse is positive 13, and we need to figure out x. All right, this is a 5, 12, 13 triple, so you need the Pythagorean theorem to figure it out to make sure I'm right, but that's what it is. All right, so we already have the sine is negative 5/13, so the cosecant is going to be negative 13 fifths. Negatives over there. All right, the cosine, the adjacent leg over the hypotenuse, and the secant is the reciprocal, 13/12. And then we have the tangent, which is opposite leg over the adjacent leg, and the cotangent is the reciprocal, 12 over, or negative 12 over 5. Okay. Excellent. So now, x is 1/2, and y is negative. X is positive, and y is negative. So if x is positive and y is negative, we're in the fourth quadrant. So I'll just make a triangle over here. Okay. Now x is the adjacent, or cosine is adjacent over hypotenuse. So the adjacent leg is 1, hypotenuse is positive 2. So what do we get for y? All right, so 1 squared plus y squared equals 2 squared. Y squared equals 4 minus 1, which is 3. So y is the square root of 3. And here we go. Cosine, we'll just go ahead and keep it this way, is 1/2. So that means the secant is reciprocal. The sine is the opposite leg over the hypotenuse. And that means the cosecant is the reciprocal. And the tangent is opposite leg over adjacent leg. So that's just square root of 3. And the cotangent would be the reciprocal, 1 over the square root of 3. Again, we have cosine, which is the adjacent leg over hypotenuse. So where's the negative go? Well, that would be x over the hypotenuse. So since it's negative and the hypotenuse is always positive, the 1 goes on the negative, and the y value is negative. So x is negative and y is negative. We are in the third quadrant. Okay, so x is negative 1, the hypotenuse is 3. What do we get for y? Negative 1 squared plus y squared equals 3 squared. So y squared equals 9 minus 1, or 8. Square root of that is square root of 4 and square root of 2, or 2 square root of 2. And it's negative. Oops, sorry about that. Negative 2 square root of 2 is y. All right, get the cosine out of the way. That's negative 1/3, so secant is negative 3. The sine is opposite leg, negative 2 square root of 2 over hypotenuse. And the cosecant is the reciprocal, negative 3 over 2 square root of 2. I always put my negative in the numerator to start with. All right, now tangent is going to be y over x, or opposite over adjacent. So negative 2 square root of 2 over negative 1, or just 2 square root of 2. And the cotangent is going to be 1 over 2 square root of 2. Cosecant is the same as the sine. So this is 1 over the sine, or the reciprocal of the sine. The sine is opposite over hypotenuse, so that means the cosecant is hypotenuse over opposite. So that means hypotenuse is 5, and the opposite leg is 1. and the cotangent is x over y. So that's negative. So that should be negative. One has to be positive, one has to be negative. So cosecant goes with the sine. So that means we have a positive 5 here. So that means y is 1 and the hypotenuse is 5. So since y is positive, that means x has to be negative. All right, so if x is negative and y is positive, we're in the second quadrant. All right, so y is 1, hypotenuse is 5, and now we have to find x. 1 squared plus x squared, plus x squared equals 5 squared. So x squared equals 25 minus 1 is 24. The square root of that is the square root of 4 and square root of 6, which is 2 square root of 6. And it's negative because it's in the second quadrant. All right? So we have the cosecant. That's 5. So that means the sine is 1/5. All right, cosine, the adjacent leg, negative 2 square root of 6 over the hypotenuse. And the secant would be the reciprocal. And the tangent is the opposite leg over adjacent leg, negative 2 square root of 6. This is a 1 here. And the cotangent is going to be the reciprocal, negative 2 square root of 6. Secant goes with your cosine, so the reciprocal. So cosine is the adjacent over hypotenuse. So secant is the reciprocal, hypotenuse over adjacent. And that's 4 over 1. So since it's positive, hypotenuse is always positive, so that means the adjacent leg has to be 1, or x is 1, okay? All right, and then the cosecant is y, that has to be positive. So they're both positive, that means we're in the first quadrant. All right, so hypotenuse is 4, the adjacent leg is 1, what is y? 1 squared plus y squared equals 4 squared. Y squared equals 16 minus 1 is 15. So the square root of 15. Excellent. All right, so let's do it. Secant is 4 over 1, so that means the cosine is 1 over 4. The sine, opposite leg, square root of 15 over hypotenuse, and the cosecant must be 4 over the square root of 15. Tangent is opposite leg over adjacent, so that's just the square root of 15 over 1. So the cotangent is 1 over the square root of 15. And sine, that's the y value. Sine is opposite leg over hypotenuse. So opposite leg is 2, hypotenuse is 5. So y is 2, and the hypotenuse is 5. Cosine is x, it's positive. So since they're both positive, again, we're in the first quadrant. Opposite leg is 2, hypotenuse is 5. And let's see what we get for x. X squared plus 2 squared equals 5 squared. X squared equals 25 minus 4 is 21. That's the square root. Okay, so now the sine is 2/5, so the cosecant is 5/2. Cosine is adjacent leg, square root of 21 over hypotenuse. So the secant is 5 over the square root of 21. The tangent is the opposite leg over adjacent leg, and the cotangent is the reciprocal of that. We write the expression in non-radical form without using absolute values. Okay, so tangent squared plus 1 equals secant squared. So tangent squared equals secant squared minus 1. All right, so here we have the problem. So that's equal to the square root of the tangent squared, which is tangent of theta. Now, where's the tangent of theta between 90 and pi? Well, it has to be negative, and that's your answer. It has to be in the second quadrant, and the tangent is negative in the second quadrant. All right, so now we have 1 plus the cotangent squared of theta. Same type of thing. That's equal to the square root of secant squared of theta, or just the secant of theta. Okay, and from 0 to 90 degrees, everything's positive, so that's our answer. Again, this is just like the other ones. This is the square root of secant squared of theta. And this is between 270 degrees and 360 degrees. So we're in the fourth quadrant. And the secant is the same thing as the cosine. And the cosine in the fourth quadrant is going to be x, so that's positive. So secant squared is secant of theta. Okay, and now cosecant squared minus 1. I made a mistake back on 98. I think it was 98. That should have been cosecant, not secant. All right, so let's do this one. Cosecant squared of theta minus 1 is going to be from the 1 plus cotangent squared equals cosecant squared. All right, so the cosecant squared minus 1, and then to get rid of the square, we take the square root, and that's what that is. So now you have the square root of cotangent squared, which gives us the cotangent of theta. And you're in the fourth quadrant. Cotangent is x over y. And in the fourth quadrant, this would be negative. So we need to put a negative sign on the cotangent of theta. Okay, so the square root of sine squared is going to be sine. And what's important here is we have theta divided by 2, which is what we're going to use this for. So between 2 pi and 4 pi. Well, if you plug 2 pi in, 2 pi over 2 is just going to be the sine of pi. Okay? And then you have the sine of 4 pi over 2, which is going to be the sine of 2 pi. So where is the sine of theta? What are the values of the sine between pi and 2 pi? That's what it's really saying. So between 180 and 2 pi, the y values, which is the sine, is going to be negative. So this answer is negative sine of theta over 2. And our last problem, same type of thing. This will be the square root of cosine squared, will be the cosine of theta over 2. Again, you plug these in. 0 over 2 is just 0. And pi over 2, oops. So what is the x value between 0 and 90 degrees? It's positive. So this is our answer. Positive cosine of theta divided by 2. Great job.